Okay, and we're back again. So we did our partial fraction decomposition so we could find out that x of s is equal to a, which is -8/5 times 1 over 2s minus 1, plus b, which we know to be 4/5 times 1 over s plus 2. Okay. And these are starting to look familiar. They look like they are, if we remember, that the Laplace transform of 1 is 1 over s. So these look a lot like that, except they have been shifted. And we've got a small problem here. This is 2s. So what I'm going to do is take this guy, and I'm going to factor a 2 out of the entire denominator and write this as -8 tenths times 1 over s minus 1/2 plus our 4/5 times 1 over s plus 2. And if we do the inverse Laplace transform on each of these pieces, then let's actually write that down. So the inverse Laplace transform on 1 over s minus 1/2, well, that looks like 1 over s, whose inverse Laplace transform is 1, but this minus 1/2 is going to give me e to the 1/2 t times 1. The inverse Laplace transform on 1 over s plus 2. So, except for that translation, 1 over s looks like 1 when we do his inverse Laplace transform. So this is going to be e to the -2t times 1. Okay. And then if we take and do the inverse Laplace transform to the whole thing now, and using the linearity of the inverse Laplace transform, we'll get -8 tenths, which is the same thing as -4/5 times this inverse Laplace transform is simply e to the 1/2 t plus 4/5, and then this inverse Laplace transform is e to the -2t. And so we have solved our differential equation using our Laplace transforms. Okay. All right. So next up, we need to talk about what happens when there are repeated factors in our partial fraction decomposition. So to help us see that, let's draw an analogy to something that's a little easier to start with. So what if I wanted to decompose 19/27ths? Well, we notice that 27 happens to be 3 cubed. And so if I break him down into fractions, I'll have to have 3 cubes, and I'll even have 3 squareds and even thirdses. So we're going to break this guy down. And if we notice that 19/27ths is 18 plus 1/27th, we can then write this as 18/27ths plus 1/27th. And that will help us a little bit. So we know then that this is going to be we're going to have a 1 here. And the 18/27ths, we can note, oh, those are both powers of 3. So that would be, if we divide by 3, that would be 6/9. And I might be tempted to put 6 here, but notice that 6 can also reduce further because 6 is a multiple of 3, as is 9. And so that this guy is 2/3. So we actually need a 2 here and a 0 there. Okay, so next up, let's take a look at him for a partial fraction like this guy. So if we rewrite him, he is s plus 1 over s times, notice that s squared plus 4s plus 4 happens to be a perfect square, namely s plus 2 quantity squared. So if we break him down, we'll need a over s plus b over s plus 2, kind of like what we did here. But we also need over the highest denominator, which is going to be s plus 2 squared. But what we need is this guy to be a proper fraction. Now, you might think that I want cs plus d because the bottom is squared. And actually, let's take a look and see what happens if I were to do cs plus d down here. Well, if I were to do cs plus d down here, then I'd have cs over s plus 2 squared plus d over s plus 2 squared. And I could do, pulling a trick that we learned on the front page, what if I added 2c to this? Then I could subtract 2c from that, and I'd still have the same thing. And I could factor out the c from this, and then divide out an s plus 2. And so that would give me, factoring out the c, I'd have c over s plus 2 when I divide out that there, plus d over s plus 2 squared. But I've already got a constant over s plus 2 covered. So because of that, we only have to look at what the factor is that's being repeated. And so we don't want this. We instead want to use a over s plus b over s plus 2 plus c over s plus 2 squared, because the factor himself is linear. Therefore, even though he's going to be squared, the factor is linear, so the numerator needs to be 1 degree less than that, which is a constant. And if we remember that this is equal to s plus 1, we can go ahead and find our partial fraction decomposition. Getting a common denominator and then doing just some baby algebra steps, we'll get a times s plus 2 squared plus b times s plus 2 plus c times s is equal to, oh, and this guy was over s and s plus 2 squared. So, okay, is equal to s plus 1. Doing a little bit of substitution here. Let's say that s equals 0. If s equals 0, these two terms go away. We'll have a 1 on the right-hand side. A times 1 plus 2 quantity squared would be 4. So a times 4 equals 1. So a would have to equal 1/4. Similarly, if we let s equal, let's say, -2, that will 0 this term and this term. We'll get -2 plus 1 is -1. And so we'll have c times -2 is equal to -1. So c would have to equal a positive 1/2. And then we've used up the things that are going to 0 terms, so we can pick anything else we want. So let's go ahead and pick, how about, I'm going to have to cheat just a little bit here. How about s equals 1? So if s equals 1, I'll get 1 plus 2 is 3, squared is 9, times a, which is 1/4. So we'll have 1/4 times 9, or 9/4, plus b times 1 times 2, which is, 1 plus 2 is 3, times 1 is 3, and plus c, which we know to be 1/2, times 1, so this is going to be 1/2, and that will equal 1 plus 1, or 2. And if we subtract 9/4 and, oops, that's a plus. So that's another 2/4. So if we subtract 11/4 from 2, which is 8/4, we find out that 3b is equal to -3/4. So b should equal -1/4. So this guy, when all is said and done, is going to be 1/4 times 1 over s minus 1/4 times 1 over s plus 2, and c, which was plus 1/2 times 1 over s plus 2 squared. And we're going to finish this guy, and then we'll go to our next video. So if we do the inverse Laplace transform for 1/4 times 1 over s minus 1/4 times 1 over s plus 2 plus 1/2 times 1 over s plus 2 squared. Okay, we know the inverse Laplace transform of 1 over s is 1, so that is going to be 1/4 times 1, or just 1/4. Okay, this guy is going to be very similar, just like we've done above. So this will be minus 1/4 times 1 times e to the negative 2t, okay, plus 1/2 times, remember that the Laplace transform of t is 1 over s squared. So if we go backwards, this is going to be t times, translation, so e to the negative 2t, because of this guy right here, times t. Okay, and we'll stop there for this video.